Consider finding an object as a beginner astronomer and learning that it is gravitationally bound to Earth. Well, Tony Dunn experienced a lot of this in 2020. According to amateur astronomer Tony Dunn, there is a second Trojan asteroid that orbits the Earth. The asteroid, 2020 XL5, is a few hundred meters across, revolves about the L4 point, one of the solar system's parking places, and is connected to a gravitationally stable zone ahead of Earth in its orbit. What is a Trojan? What kind of thing is it though? Do Trojans exist on every planet? To find out the answers to all of these questions, watch this video with us. First of all, what are Trojans? A Trojan is a minor celestial entity, typically an asteroid that travels in a stable orbit 60 degrees ahead or behind the larger body around one of the so-called Lagrange points and shares its orbit with it. Trojans have the ability to share planetary or giant moon orbits. The Trojan asteroids, Jovian Trojans, which orbit close to Jupiter's Lagrangian points, are what the word Trojan originally referred to. They have traditionally been referred to by the names of characters from Greek mythology's Trojan War. According to tradition, the figures from the Greek and Trojan sides of the war are represented by the names of the asteroids orbiting close to Jupiter's L4 and L5 points, respectively. For instance, we discover 588 Achilles and 1172 Aeneas. What materials and how big is a Trojan made of? Trojan is a space rock, like other asteroids. We are aware that certain asteroids are the size of rocks. Some are the size of football fields. Astronomers occasionally debate whether or not extremely massive asteroids should be referred to as planets because some of them are almost as enormous as actual planets. Rock, metals, and other materials are used to create asteroids. Some even contain water, astronomers say. Sometimes, asteroids with a stone composition resemble loose mounds of debris. Astronomers can learn more about asteroids thanks to meteorites that are frequently encountered on Earth. An iron meteorite may contain cobalt in addition to its typical composition of 91% iron and 8.5% nickel. Oxygen, silicon, magnesium, calcium, and other elements may be present in stony meteorites. The majority of Jupiter Trojans are D-class asteroids, which are most common in the asteroid belt's outermost areas. Asteroids of the P or C type have been categorized extremely seldom. It's possible that some of them contain water even though it hasn't been found on any of them yet. Current research suggests that the Jupiter Trojans are primarily composed of water ice with a covering of dust, similar to comets or Kuiper belt objects. Observations are still ongoing, though. What exactly did Tony Dunn discover? And why was it so crucial? Due to the fact that Earth Trojans spend the majority of their orbits in close proximity to the Sun, they are difficult to find. Apart from the fact that the aforementioned is true, the fact that the aforementioned is true does not mean that the aforementioned is true. Instead, the objects follow routes that circumnavigate the L4 and L5 points, which are shifting as Earth revolves around the Sun. According to Bill Gray of Project Pluto, 2020 XL5 is most likely a commonplace piece of rock that came close to Venus and was thrown into an orbit with a period very close to a year. The orbit should be stable for 2,000 to 4,000 years, according to retired Italian chemist Aldo Vitagliano, but gravitational drags will eventually cause it to change orbits. We may need to wait until more observations can be made in order to determine the orbit of 2020 XL5, according to amateur astronomer Sam Dean, since it has only been detected for a short period of time. As you can see in this simulation, it even approaches Mars' orbit, the one in orange, which makes it a really interesting object in that regard. For starters, this means that Mars will eventually destabilize this orbit, causing the object to move away and possibly escape to another location or even turn into a Trojan of Mars. It might be argued that Trojan asteroids near the Lagrange points and on a few other planets are evidence of the existence of such gravitational sites. These points' existence enables people to install telescopes and spacecraft at Lagrange points, which enables them to maintain their location with respect to the Earth while consuming no fuel. We used to refer to the Lagrange points as the parking areas of our solar system because this is amazing. What about the original Trojan from Earth? What year was it found? Please be sure to like or dislike the video before we respond to this question so that we can keep getting better and making these films better for you, the viewer. Every few hundred years, the first Earth Trojan, known as 2010 TK7 since it was found in 2010, travels within 20 million kilometers, 12 million miles, of Earth. It is presently drifting away. According to models, it can remain in a 1-to-1 resonance with Earth for roughly 250,000 years. Do Trojans exist on every planet? Most likely, the answer is yes. Yet, in order to answer why, we must first define a Lagrangian point. As we previously stated, Trojans are asteroids that are gravitationally bound to L4 or L5, two stable Lagrange points. There are places in space known as Lagrange points where the gravitational pull of a large two-body system, like as the Sun and the Earth, but they could also be the Sun and Jupiter or the Sun and Mercury, produces stronger zones of attraction and repulsion. These can be employed by spacecraft to lower the amount of fuel needed to maintain their position. Joseph-Louis Lagrange, an Italian-French mathematician, is remembered by the name of Lagrange points. A small mass can orbit in a regular pattern with two larger masses at 5 specific places. The Lagrange points are locations where the centripetal force necessary for a tiny object to move with two massive objects is exactly equal to their gravitational attraction. In his prize-winning essay sur le problème de trois corps, 1772, Lagrange addressed this general three-body problem, a mathematical conundrum. We may state that there are a set of 5 sites in the circular restricted three-body problem where, if we place our spacecraft, it will never move in relation to the two bodies. The Lagrange points are these. Yet the first thing we should always consider when we reach an equilibrium in a dynamic system is whether or not it is stable. 3 of the 5 Lagrange points are unstable, whereas the other 2 are stable. The 3 unstable Lagrange points, L1, L2, and L3, are located along the line that connects the two massive objects. Unstable simply indicates that any object that is placed near, but not precisely on one of these Lagrange points, will move away from the Lagrange point. The stable Lagrange points, marked L4 and L5, form the apex of 2 equilateral triangles that contain high masses at their vertices. Earth's orbit is led by L4 and followed by L5. Each planet therefore has its own L points, which implies that each planet may also have its own Trojans. And it really is the case. Moreover, 7,000 Jupiter Trojans, 9 Martian Trojans, around 22 Neptunian Trojans, 2 Earth Trojans, 2 Uranian Trojans, and 1 transitory Venusian Trojan are currently known. Saturn, what about it? Actually, we haven't found any Trojans around Saturn yet because of the proximity of Saturn to Jupiter, basically because of planetary interactions and because Jupiter is really large. They don't truly lack them since they aren't present. Saturn just seems to be lacking them. No significant ones have been discovered, but they are most likely there or may even be very small. We think this is primarily due to Jupiter's gravitational interactions, which means that Jupiter probably just took them all and now they are orbiting the other planet. In any case, the same configuration, in which much smaller Trojan moons might share their orbit, can naturally emerge when the primary object is a planet and the secondary object is one of its moons. The Saturnian system contains all of the known Trojan moons. Trojans of Tethys, Helene, and Dione, Telesto, and Calypso are also polydeuces. Do we have a chance of discovering more Trojans from Earth? The search for Earth Trojans is being intensified by astronomers. The Catalina Sky Survey has increased the area it covers, and once the Vera C. Rubin Observatory is operational in a year or two, a group there is also preparing to do observations. If the planet's orbit hasn't changed since then, a population of Earth Trojans should have persisted. Additionally, their existence has other effects. To help explain why the leading hemisphere of the Moon has around 70% more youthful craters than the trailing side, a disparity that current models can't account for, researchers may look for ancient Trojans. The extra juvenile craters could be explained by Earth Trojans slowly ejecting from their orbits. In 2017, two spacecraft on their approach to NEOs examined Trojan regions, but neither the Japanese Hayabusa 2 or the NASA OSIRIS-REx discovered anything. The observations, however, were not conclusive, and Renu Malhotra, University of Arizona, argued in 2019 that the Earth might still be home to several hundred Trojans that are at least a few hundred meters in diameter, or a portion of the 10,000 or more such near-Earth objects. Here are some did you know that facts that we have compiled for you before we wrap up this movie. Do you realize that 617 Patroclus is the second largest Jupiter Trojan? Its circumference is 140 kilometers, 86.9 miles. The asteroid 4709 Enemos, with an albedo of 0.18, has the greatest albedo of all known Trojans and the Jupiter Trojans combined. This area of high albedo might contain water ice. At 1.7 and 2.3 m, the Jupiter Trojans 911 Agamemnon and 617 Patroclus have incredibly modest absorptions that could suggest the presence of biological materials. Around 17% of Jupiter Trojans are unstable over the solar system's history, according to simulations. Here's where the video ends. Thank you everybody for watching. What are your thoughts on Trojan asteroids? They astound you, right? Do you have any more questions for us? Tell us in the comment section below and see you on the channel again soon.